Hello everybody, today we're gonna see about different types of regression analysis in our software. There are around 15 types of regression, so we will see the first four types of regression for this tutorial, and we will deal the remaining regression types in upcoming tutorials or video. So for today's tutorial, I only stick to linear regression, again for logistic regression, polynomial regression, and finally we will see the quantile regression. Coming to the concept of linear regression, it is the simplest form of regression in which the dependent variable is continuous in nature, and the relationship between the dependent variable as well as the independent variable is assumed to be linear in nature. And this type of regression is classified into two forms, or in two types. The first one is the simple linear regression, and the second one is multiple linear regression. Simple linear regression means when we have one dependent variable and one independent variable or predictor, while in the case of multiple linear regression, when we have one response or dependent variable and when we have a number of predictors or more than one independent variables. And there are a number of assumptions regarding to the linear regression. The first one is there must be linear relationship between the independent and dependent variables, and the second assumption is there should not be any potential or possible outliers in your data. And the third one is there should not be heteroscedasticity. That means there should be homoscedasticity, and the sample observation should be independent, and again also error terms should be normally distributed with a mean is equal to 0 and with a constant variance. And in fact, lastly, there is absence of multi-collinearity and autocorrelation in our data. So in order to do that, I already imported my data in order to save our time, and our data frame is here is SATPH, GY, DI, HI, and end with the TT. Again, so I type this data. Then let's create multiple linear regression. In order to do simple linear regression, we will cancel all these predictor variables and left with one predictor variables or one independent variable. So type this GY stands for response variable or dependent variable, and as explained by planted harvest index, grain protein content, and hectoliter weight. So if we do this, we'll get the linear regression. So type this and submit to our studio, so you can get the result of the multiple linear regression. So the first types of regression is linear regression, which is which is the model created by this linear model. So you have to use the LM function, and you can get the detailed information about the R square, about the model. That means the R square, the adjusted R square, and etc. The second type of regression is logistic regression. And this regression is preferable when the dependent variable is binary nature. That means having two categories. That means 0 or 1, true or false, male or female. But in fact, logistic regression is classified into different forms. The first one is the binary logistic regression. So under such conditions, the response variable is dichotomous in nature. That means only the possible outcomes is as 0 or 1 or true or false. And these values have have only two variables, that means 0 and 1. While in the case of the other types of logistic regression is multinomial regression. So in this case, the response or the dependent variable has 3 or more possible outcomes, but these values have no specific order. For example, you can take an example as age or gender, age maybe it is different in terms of number, age is female or male, maybe it is marital status, it is maybe married, unmarried, or widowed or single, and such we will classify in such way. So this value have no specific order. And the last one is opposite of the multinomial. That means the ordinal. That means the response variable has three or more possible outcomes, but the value have a defined order. For example, grade A up to F. A means is excellent, B is somehow is good, C is again satisfactory, F maybe it is flat, so the one who got F will not pass to the next examination or to the next year. So on such conditions, or even also you can give the scale. For example, 1 is equal to very strong, 5 maybe it is weak. So it have what? The value of some defined order. So logistic regression, the first one is the binary logistic regression. That means the response variable containing the dichotomous nature. That means 0 or 1, true or false, and etc. And the second one is the multinomial, which is the response variable has three or more outcomes, but the values have no specified order. When we come to the ordinal, it is similar with the multinomial, but the difference is the value have what is defined order. So how to do logistic regression in R? You have to use this function. In our cases, here is the method that I'm going to use. So I change here is di into factor. That means from my data, di is like different options like 3 3 1 4 2, and again in different techniques. So you have to use the function for logistic regression is GLM. In the case of linear regression is what? LM, but here is GLM, and you have to indicate here is your response variable. That means ST for me it is a dichotomous nature. That means 0 and 1, 0 and 1, 0 and 1. So if it is this, it is very simple, and this type of regression is a binary logistic regression. So followed by different response by different independent variables, and you have to indicate that as equals to LR, because LR is our data name, family is a binomial. Why we say binomial? Because ST is here is our response variable. ST is what? It is dichotomous in nature. But if it is if we have more than 2 or let's say 3 response outcomes, so we will change this into what? Into multinomial. And if we have defined order for that outcomes, so we have to change this into what? It is ordinal. So by this way we can perform logistic regression in our software. So type this, submit to our studio. So this is about logistic regression, and if you want to find the confidence interval using the profiled likelihood as well as the standard error, so you have to use the confit function and you have to feed the WAC2 which represented all this logistic regression. Then again you can also the default method which is dealing using the standard error, so confint.default, then again feed this one, so you will get a more or less similar result with the two methods. Yeah, more or less the two methods are similar. So by this way you can find the confidence interval for logistic regression. Coming to the third types of regression is polynomial regression. This type of regression is suitable when you want to fit nonlinear equation by taking a polynomial function of the independent variable. First, you have to check whether or not your data is derived from the linear, or you can check whether it is linear or not. So you have to incorporate this package ggplot package in order to create ggplot frame, then
you have to use a function ggplot, then it's followed by parentheses. In the parentheses, LR stands for our data name, and the x-axis, this means its axis, which is x and y. X is denoted by tt, that means our independent variable, while the y is equal to pt, is productive tiller for the response variable. Then type this and submit to our studio, then we'll check their linear relationship. Yeah, as you can see, it's not linear. It is somehow it is a polynomial type or quadratic type. So it is recommended to use the polynomial function. So in order to do that, you have to use the LM model, which is similar with the linear regression, but the difference here is a poly. That means before that, pt is our response variable, then explained by the polynomial function of the predictor or independent variable. That means total tiller, then 2 indicate is the power of 2, that means total tiller square. So you can change also, or you can compare by powering of 3 and 4. And then finally indicate your data name in this way. So type this and submit to our studio, then you can get this value. Then the last regression types for this tutorial is quantile regression, and this quantile regression is the extension of linear regression, and we generally use it when our data contains outliers, when our data is highly skewed, and when our data contains heteroscedasticity. So if you face such type of difficulties or such type of problems, or if the assumption is violated for the three things, that means outliers, high skewness, and also heteroscedasticity, you have to use the quantile regression. So in order to use a quantile regression, we have to incorporate the package quantreg. So if you haven't this package, use this syntax and incorporate your studio. So I already have this package, so I will call this package into RStudio. Then in order to use the quantile regression, we have to assign any names that you want here, but you have to use this function, that means the RQ. RQ stands for the quantile regression, then response variable explained by the plantate, and indicate data is equals to LR. So by this way, you can get the quantile regression. So type this and submit to RStudio, so you will get such type of results. Then over here, even you can compare by the graph. For example, you have to use the plot function, then write gy, which stands for the gradient or our response variable, explained by plantate, and our data is equals to LR. Then type this and submit to our studio. So by default, this will give us the linear one. Then again, we will proceed to the next one. Again, it is similar to that one, but we will create the AB line, then go for the last one. So by this way, we can compare. The first one is what? It is a general description, but the second one is a linear model. That means the assumption is not violated, but the third one is when the assumption is violated. So type this and submit to our studio, then we can check the graph. Yeah, the first one is the one with red line, it's a linear regression, but the second one is the quantile regression. More or less they are similar, but if we divide or if the assumption is violated, it will clearly say. So in order to compare the two, that means the linear regression as well as the quantile regression, you have to use these techniques to compare. Let's wind up our today's tutorial by telling you some advantages of the quantile regression over linear regression. The first advantage of the quantile regression is it is very quite beneficial when heteroscedasticity is present in our data, and secondly, it is very robust to outliers in case if we face difficulties in having outliers in our data. And thirdly, the distribution of dependent variable can be described via various quantile, that means 25, 50, or 75 percentiles. And lastly, it is more useful than linear regression when our data is highly skewed. So this is all about today's tutorial, and we try to see about the linear regression. That means simple and multiple regression. Then we also seen about logistic regression, especially the three different types of logistic regression. And finally, we try to discuss about the polynomial as well as the quantile regression. So this is all about today's tutorial. And as usual, if you have any comments and suggestion or any feedback, you can provide me through my email or YouTube comment box. So thank you for watching. Have a nice time.